Hello everyone, today let's take a look at QP29, a cool pigeonhole question where we have 51 ants on a square with a side length of 1. So it's asking us, if you have a glass with a radius of 1/7, can you put your glass at a position on the square to guarantee the glass contains at least 3 ants? So here's my 1x1 square that I'm going to place 51 ants on. And you can kind of tell it's going to be pigeonhole, right? I want to break this square up into sub-intervals such that at least one is guaranteed to have 3 ants. And I want these sub-intervals to be as small as possible so that our glass of radius 1/7 has the highest chance of covering it. So we have a circular glass. Obviously, I can't break up a square into a bunch of circular subintervals. So basically what we want to find is the biggest integer x, right? The number of partitions, such that when we split up the 51 ants into x different groups and we take the ceiling of it, it's going to be equal to 3. And this is just the pigeonhole principle, meaning that we're guaranteed to have at least 3 ants in one subgroup. And when we solve for x here, we're going to get 25, obviously, which is convenient because that is a square number. So we can partition our square over here into 5 rows and 5 columns. So now we have a bunch of smaller squares, right, all with side lengths of 1/5. And we know that this partition is the smallest that we can go with the size of our subgroups while still guaranteeing at least 3 ants in at least one of these squares. And that's just because even if I have a distribution where every square has 2 ants, well, now I've only used 50 ants, right? 25 times 2. So I still have one more ant to place in one of these squares, and whichever square I place it in will have at least 3 ants. So this is the best strategy that we can come up with, right? Basically, we partition our square like this, and we see whichever square has at least 3 ants, well, we're going to put our cup over it, right? But now the question is, can a glass of radius 1/7 cover a square of side length 1/5? So let's come down here and draw it out. So here's my 1/5 by 1/5 square, and here's my circle of radius 1/7. And in order for a circle to fully enclose a square, well, it's going to have to cover the furthest points away from each other on that square. So that's going to be the diagonal. And the length of this diagonal is just going to be, if we use the Pythagorean theorem, we're going to take 1/5 squared plus 1/5 squared, 2 on 25, and then we're going to take the square root of that. So we get root 2 on 5. And if we look at our circle, we have radius 1/7, so that obviously means we have a full diameter of 2/7. So now, is 2/7 greater than root 2 on 5? And if it is, we're going to be able to cover this square with this glass. Okay, so let's just square both sides first of all to get rid of that root 2. So we're going to have 4 on 49 over here, and we're going to have 2 on 25 over here. And then we can multiply each side by 25 and 49. And on the left-hand side, we're going to have 4 times 25, which is 100. And on the right-hand side, we're going to have 49 times 2, which is 98. And is 100 greater than 98? Yes, it is. So we're going to be able to enclose this square with this circle. So now, can you put your glass at a position on the square to guarantee the glass contains at least 3 ants? Yes, we can, right? So one more time, the strategy is we partition our square into 25 subintervals, and that will guarantee us that at least one of them has at least 3 ants. And then we see whichever square has at least 3 ants, and we just place our glass over it, and we know the glass will fully enclose it because we just showed that down here.